Hey guys, it's Timbot hanging out here at Steamlabs. I'm about to kick off the CNC portion of my arcade cabinet project. So that is the arcade cabinet build that I'm doing to showcase the work of the kids in the Unity game development program. Now if you didn't know it, Steamlabs also has Adult Maker programs, and I checked in with Sayyad, one of the grads from our Adult Maker Generalist program, on CNC Operation. Let's take a look.
So then once you're happy with the toolpath and the preview looks like what you want it to look like, you then close the preview mode, and just for kicks, recalculate all toolpaths just to make absolutely sure, and then save toolpath. Now the important thing here is to output all visible toolpaths, because if you have two separate toolpaths, sometimes it only outputs one and then it only does part of the job. So double check that. Save toolpaths. Figure out where you want to save the toolpaths to. I'm going to call this one plate because it's a lower plate for something. Drop it on my USB stick. And then for all the fun we can have, I'll drop it onto the shop USB stick as well. Separate operation just because it's there whenever it launches. And we'll save it to, what do I call it for, plate. It saves as ISO files, which is what this particular CNC milling machine needs to run.
Seems so strange, doesn't it?
It does.
ISO files.
Yeah. This is usually disk image files, which is why it's strange. Always save your changes. If it gives you any weird problems, mostly just hit cancel and things go back to normal. Here is your spindle speeds. So I'm going to be setting, as per the guide on the website here, which is full of stuff, spindle speed should be S4, which in this case is going to say F4 on this machine, which is 12,000 RPMs, but I'm probably going to boost it up to 15,000. It just depends on how it sounds. It's almost intuitive at this point. It's not, not ideally, you got to feel it out. It's a machine after all. It's not really...
You can manually adjust it.
Yeah. Whenever you use a USB stick in this machine, and any machine, always eject correctly, because it could be writing or reading to or from the drive, and if it is doing that, then it can corrupt the data and then it won't read.
Right.
Which is certainly not what you want to be troubleshooting while trying to cut something, especially while you're paying for your time. The machine itself, two main controls. If you want to look down there, we have a great big wheel, power on. We have a handy little button which makes it make that noise. There you go, you can watch it. So it boots up, you get the fans going in the machine, and then the first thing you want to press on this handy little guy, which is your fancy remote control with a totally old school interface, USB on top, all axis home, which is to say, figure out where all of your axes are.
So the green button.
The green button. Well, origin OK. It says OK on it. So watch the machine. There it goes. And it's going to it's already gone all the way over to the left here on the x-axis, and now it's going to go all the way over to the front on the y-axis, and you want to not be anywhere near there because it doesn't know if you're touching it. It doesn't care. It's going to keep moving.
Or anything that...
Yeah, if you have something sitting on there,
bed or anything.
no, a chunk of wood, your purse, whatever, it's going to just shove it off. Yeah, so what we're going to do here is I'll show you where I'm going to zero to. Pressing these buttons and holding them down makes it move along fairly quickly most of the time. So if you want to get the camera around this angle here, if you're in line here, that is the wrong place to zero because it's going to hit the clamp. So when you're zeroing things like this, you want to go a bit up beyond that and then double check that by just seeing where that's going to line up. So if you want to come back around to the front of the machine again, we'll see where that looks, whether that looks like it's close enough. And you can see it based on the lines in the grid on the spoil board, it's not quite there yet. So we can shove it over a tiny bit, and that's probably about right for a zero. The importance of having the zero be a clear and open area is that the machine, when it first starts going, again, will find the zero. Right. So if there's a clamp in the zero, it's going to hit the clamp. If there's a piece of wood in the zero, it's going to hit the piece of wood. It's just, it doesn't know what's there unless you tell it what's there.
Right.
Anyway, so it starts at zero, no matter what. Make sure your zero is a clear area. Once you're happy with that, you can hit X, Y to zero. Now let me just double check. It's good practice to get close and just double check everything, like really, really manually. And in this case, I'll move it just a smidge, and that should be enough. I have an extra 8-10 centimeters to play with. That's fine. So once you're done with that, X, Y to 0 button. Now these are all zeros, as you can see. Z, being the vertical axis, thinks it's a 63, which, you know, whatever. What we're going to do about that is move it off 0, and then install the bit, and then 0 the machine vertically, which it does automatically. Here's a fun excuse to use the speeding up features of your camera to make this a little bit quicker. So, bit comes in a fun little case. Don't leave the case on the machine. Don't leave the bit on the machine, but, you know, for the camera. This handy nut should not leave the immediate vicinity of the machine, and ideally should be put back exactly where it's from every time. This is a collet nut right here, and that's a cool one because if you look inside, I'm sure you can see this. Can you see that all right? Mm-hmm. A little ridge in there?
Yeah.
That's going to hold the collet, which I'm going to go grab. Follow me over to the drawer, have a look at the collets. What we have here in the top drawer is this handy little collet carrier. So you have different...
Are they labeled?
Yes, each one has, this says 8/7, I have no idea what that means, but for example, this is a 3/8, I don't know if you can see that there. And this here is the 1/4 that we're going to use in a minute. And this big guy here, that's probably 12 millimeter. So it's 12/11 on it. The metric ones can move around.
Pretty big.
Yeah, it's pretty big.
Look at this was a ½ inch maybe.
Well, yeah, this one here is too large to even label. But yeah, there's a whole selection here. You want to use the right one for your bit. If it's too small, you're going to have to spread it apart and that damages it. If it's too big, you have to clamp it all the way down and that damages it. So it's very important to have the right size collet.
So you want your shank to basically just slip in.
Yeah, and there's a difference here.
Sit comfortably in it.
Yeah. So the one on your left is a 6 millimeter, and this is the 1/4 inch, and they're pretty dang close.
Yeah.
You don't want to use the wrong one. So always check. It should be written down here. If not, grab a caliper and figure it out properly. But don't use one if you're not certain.
Yeah. Hopefully your bit is labeled as well.
Yeah, and also you should know what you bought. So
Yeah.
that's part of it. Let's install this guy. Collet sort of sits a bit loose. Push it down, and then push it over, and it should lock into place. Oop, unless it doesn't want to. With a click.
There you go.
So, clicks into place. Hold on. Need to make the noise. Nope. Yeah, well that was it then. Kind of a quiet click. Maybe it's time to clean this thing. It's got sawdust in it. But that's it. So it goes in at an angle, clicks into place.
Perfect.
And at that point, you can insert your bit, which again should just, see how perfectly that fits? Nothing's stressing, nothing's pushing out of the way.
Yeah.
Put it in. You don't want to have it touching the actual flutes here because it will break them. It's carbide, it's very fragile.
Right.
So you want to have it on one of the smooth
When it
flats.
tightens, you don't want it tightening the flute.
Definitely not, no, because it'll snap them. You'll have little chips. In the end, it should sit, somewhere along the smooth. You can go all the way in if you want to, but it really doesn't make too much of a difference. And that's going to hold it. It's not going to pop out anymore because now it no longer springs. It's holding it in place because of the bit. And that you then want to carefully, and I like to turn the spindle as opposed to turning the nut, carefully tighten into place, just finger tight to start with. See that where it stops? That's great. That's most of the way there.
A clockwise turn or
I'm actually turning the spindle, clockwise and holding the nut steady.
Yeah.
Or I'm turning the nut counterclockwise.
Okay.
But it only works the one way.
Right.
So
If one doesn't work, the other will.
yeah, and don't force anything. Even with these wrenches, you don't want to go too crazy.
Yeah.
It should be snug, but not ridiculous. And you should probably turn it the right way too. And then just go. You'll feel it, right? Like it's going to actually feel tight, but not crazy.
Yeah.
But like any drill, if it
the collet's going to be applying the pressure to all sides of it. So
yeah, most of your mechanical retention there is just the collet because it's the collet. The way collets are designed is basically like a spring that wraps around and pushes evenly on, say, 8 points. So when you tighten this thing down, all it does is make the collet squeeze, just so, keeping it exactly centered. Watch this spin, see? So you can double check that if you want once you put the bit in, and it should not wobble, should not deviate from center, should not be offset on any side. If it is, it will basically self-destruct the second you spin up the spindle, because that's 12,000 RPMs on an offset piece of metal. No bueno. Yeah. You then have to zero the machine vertically. So I like to get it as close as possible. That's pretty close, actually. I don't know. But we'll go a bit closer with the Z. So you want to go low, not too low, because if it goes too low, it'll break the bit on the spoil board. This handy little thing here lives Generally, around here, it doesn't move much. The head doesn't move fast enough to dislodge it. And then this little wire here lets the machine detect the presence of this disc.
Yeah.
So what you do is you put the disc underneath your bit, and what you want to do is, can we get this all in the same frame here? You want to press on-off a menu simultaneously, which is why there's a green frame. And this will take a few seconds. So again, you can speed up the video. It's going to move down in like 0.5 millimeter steps. Until such a time as it actually contacts that disc. And all it does is just touch off of it, and then it knows exactly where 0 is. It knows how thick the disc is. And based on that, it can subtract it from the height of the workpiece. And you'll see it rises up to 81.7, which I suspect is probably somebody's birthday somewhere at the factory in China, but you know. Right? I don't, you know, there's some random numbers here. So that's the machine zeroed and set up correctly. So now if we hit origin, it should hop back to the 0 that we already set. So now it's sitting back at 0. And let's see there. Is it good enough? Yeah. So now the next thing to do is to get the machine to read the file. So this is going to be a bit of a dodgy process anyways, no matter what you do. It doesn't actually like USB sticks that much. This one works. Somehow the cheaper the better, I think, for the USBs. But you want to watch it while it's reading. It's going to blink for a while and then stop blinking. And at that point, it's ready to go.
It's decided to accept this.
Yeah, exactly. Blink, blink, blink. It's still blinking. Why is it still blinking? All right.
You know that the key has to be formatted to FAT32?
That's correct.
Yeah.
Yep.
Even exFAT? It
Does
will
not like it. No, it refuses. So it's using super old school,
Yeah.
whatever controller is actually doing this.
Old school's best school.
Well, old school works. It's reliable. You know, it's worked the same for 30 years or whatever, so probably longer for FAT. Yeah, so that's set up like so. And now we want to find the file. So we're going to go run, pause, delete, which is, you know, obviously run makes sense. Reads the USB stick, says you want to use USB file, internal file, or recent file. Recent file, sometimes if you're running the same job over and over again, but usually what you're going to do is a one-off thing off the USB stick, to which you reply, okay. So previous file, then you have my file, which you can select, right?
Yeah.
And then you hit okay. Then it asks you how fast you want it to go. I generally leave this stuff alone, only because I'm going to be playing with it in a second anyway. So once it spins up, once it starts going, then I adjust the speed to the right sound. So yeah, it'll handle way more RPMs than this. Work speed here. This is what is it? Centimeters per minute or something? Millimeters per second. There's a particular. It's on the website anyways, but that's how fast it actually is moving, not how fast it's spinning. So yeah, let's let it go. So in this case, once you're happy with it, right, hit OK. See that? Had that been a clamp, it would have smashed it. That's where 0 is. It gives you an 8-second countdown, because 8's a lucky number in China.
Oh, I never noticed that.
I'm pretty sure. And we're off. So, get in there, have a look. Those chips are okay. They just speed it up. So if you want, you can speed it up by pressing the Z+. Hear that noise? Or slow it down. So you're looking for chips that are kind of, you know, chippy shaped. For now, I'll leave it at 7. Okay. Can you still hear me okay, do you think? Oh, but can this thing hear me? Okay, so I'm going to fire up the vacuum cleaner and say how to do that. So, vacuum. hit OK to let it know that it's done. I would recommend moving it off the workpiece and just, having a look at it. So move the head, move the whole, move your spindle off the workpiece, and then just have a good look. Make sure it went through everything correctly. Maybe fire up the vacuum and, double check your tabs. But the idea is that you should be able to see through any cuts you've made to the spoil board below without having to actually cut into the spoil board. It's very precise, very small margin for error there.
Yeah.
But that's a pretty good cut, I would say.
Yeah.
You want to err on the side of having too much cleanup.
That definitely worked out.
Yeah, it worked out okay. Again, it's close to the edges, but in this case I have more cleanup than damage to the spoil board. If you go too deep, you'll scrape the spoil board and then somebody has to replace that. And if you don't go too deep, well, you just have an extra couple seconds of filing to do, so no big deal.
Yeah.
So it's always better to err on the side of not quite deep enough than too deep.